Okay, everybody, welcome back. Today we are going to be practicing some questions of Q, and my screen might look black and white. That's because I have used a color filter to make it grayscale, so that uh, my eyes get a bit less exhausted when practicing and doing stuff. So, anyways, I just don't want to put too much strain on my eyes with all of the colors and everything. So, uh, anyways, now we are going to be practicing Q starting from the beginner questions. The first one was just simple Q with push and pop and front and back. So I'm not doing this one. I will be starting from the second one. In this we had to reverse the first k elements of the Q. So for example, we are given 1, 2, 3, 4, 5, and we have to reverse till about 3. So these first three characters will be reversed: 3, 2, 1, 4, 5. So what I did for this is I first had a Q, and then I created a stack, and then I pushed the first k elements of the queue, popping from the front. I pushed them to the stack, and then from the I created another queue called result. So from the stack until the stack gets empty, I pop and push to the result queue, because as we know that stacks, whenever you like pop elements from the stack, they will be in reverse order. So that is basically what I did, and then the rest, I just put the rest of the elements from the first queue called queue to the result queue, uh, using the front operator. So popping from the front, and then I just printed out the result. You can also do it in place if you want to. What you have to do for doing it in place is that you add these first elements to the stack, you pop and add them to the back of the initial queue, and then the rest of the elements, which is going to be n minus k, those rest of the elements are going to be continuously popping from the front and pushing to the back. That is all you have to do. Anyways, now we will move on to the next question, which is the third one. You can also try solving it along with me if you want to. I will mute myself now. You should also practice them. That's it. Okay, so we have solved the third question as well. In it we had to generate binary numbers from 1 to n using q. I was really confused how I will be using q in this case, because as we know, the way we usually convert a number to binary is by, you can just continuously like kind of divide it by 2 and stuff, but convert it to the powers of 2 and then you can convert it to binary. But so I was really confused how to use a queue in this, so I asked ChatGPT, and the solution that it gave is quite intuitive and simple. So it's kind of how we use recursion. So for example, the way I always use recursion is usually in the scenarios when there can be two possibilities going ahead. So as you know, you get those trees in recursion, like with all the possibilities. So that is the way we do it. So it is kind of same in this case. What we are doing is, first of all, we push a 1 to the queue because we are printing binary of all of the numbers till n, from 1 to n. So the first one is always going to be 1, and then we run a for loop, and first of all we print whatever is in front of the queue. Then we take that front and we add either a 0 or a 1 to it, because obviously there are only two possible bits, and going ahead we can only like add these two in the front. So first we are going to be adding 0 and adding into the queue, because when we pop, the 0th one should be popping first from the front, because moving ahead, first you have 1, then you have 1 0, then you have 1 1, then you have 1 0 0, 1 1, 1 0 0, 1 0 1, 1 1 0, and 1 1 1, stuff like it moves like that. So to make it work, you just take whatever is in the front, you add a 0 or a 1 to it, because there can only be two possibilities for the new units place digit. So that is the way you do it, and each time you just print out the front, you just pop out the front, and to the front you add either a 0 or a 1, and you add it to the list or to the queue, and so that is how you do it. It can be a bit difficult to understand this one specifically, because this is more of a BFS approach, you can kind of say, according to what ChatGPT told us. And since we already use Q in BFS, it is supposed to be quite intuitive. But like for example, even I don't remember graphs and trees that well right now. I have to practice all of that, so can be a bit difficult for you to understand as well. If it is, just give it a try, give the solution a try, and now we can move on to the next one, fourth question. You can also try it out with me if you want to. I will mute myself now. Okay, so I've solved the fourth question as well. It was quite simple. We just had to interleave the first half of the cube with the second half. So basically, for example, this is the first half 1 2 3, and second half is 4 5 6. So the first element of the first half, and then we put the first element of the second half, then the second element of the first half, and then the second element of the second half. That is how it goes. And so what I did for this is I created a queue called first half. In it I put the elements of just the first half, and then I created another queue result. You don't have to create another queue result, you can also use the original one, but doesn't matter. So then you just first put in the front of the first half, and then you put in the front of the second half, which is the original queue, and then you just print out the result. Very simple. You can ask ChatGPT if it is a good enough solution or not. Let me do that quickly. So it is basically telling us to use a DQ if it is allowed, uh, to make it like more space optimized. But as I said, you don't necessarily need to use that. You can just use the original one. You just first put the front of the first half in the original one, then you pop the front of the original one and you put it in its front, and you do that about n by 2 times, so about like half time. So only half of it is there. So that's the way you can do it. Very simple question, very simple solution. Now we can just move on to the next one. You can also try it out with me if you want to. I will mute myself now. Okay, so we have solved the fifth question as well. This was really simple. We just had to check if the given Q was palindrome or not. So in this case, to make my life easier, I just used a DQ and I just ran a while loop until the DQ became empty. And in the while loop, I just checked if the front and the back of DQ are equal or not. Because if they are not equal, then it is not a palindrome. In that case, we can just directly return false. Otherwise, we can pop from the front and the back. And if the DQ becomes empty, then in that case, it was a palindromic Q. So we can just return true in that case. Implementing this using a queue, I think we could have used something like a stack, but I'm not sure. Like you can't directly just do it with a queue because you will have to check the front and the back, both the elements, unless you have a back or a reverse queue already set up. So, anyways, let us ask ChatGPT if this is an efficient enough solution or not, and if there's a really good way to implement it using just queues or something. This is my solution to problem 5th. There are more. Well, I don't think there can be a more efficient solution since we have to use Q anyways. Practical inputs, however, there are few observations slightly. Okay. Now this dq.empty is redundant. I already know that, but okay. Random access is also allowed in a DQ, so you don't necessarily have to pop from the front and the back continuously, because that will obviously be more extensive, you can say. So it won't be the most efficient solution. So you can obviously use the random access property and use 2 pointers from the front and the back and just check it like this. Basically how you would normally check it in a vector. That's the way you can do it using a DQ. Yeah, so if Q must be used strictly, this is what we need to know. Copy elements to a stack to reverse. Yes, exactly. So it is doing it using a stack. I just did not want to do that right now. So anyways, we can just move on to the next one, which is 6th question. You can also try it out with me if you want to. I will mute myself now. Okay, so we have solved the sixth question as well. In this, we just had to use two queues to create a stack functionality. So what I did for this, I took two queues and I took a variable integer called top. Initially I was calling it top, and I was also calling the function top as top, so it was causing an error. Then I changed it to TP, so now TP is the top most element, you can kind of say. I only did it so that I can get the topmost element in O1. Anyways, so what you do is whenever you want to push the element, you just push the newest element to the first queue and you update the top element as TP, which is going to be equal to n. When you want to return the top, you will just return TP, and whenever you pop, what you are going to do is you are going to be popping until there is only one element left in the Q1, and you will be adding the rest of the elements to Q2, and then you will pop that final element from Q1, and then you will be taking all of these elements from Q2 and pushing them back in Q1, but this time you will also be keeping a track of the new top element. So just basically keep updating top as Q2.front, or basically the one you are pushing. The last one that you are going to be pushing is going to be the top, and it is going to be updated accordingly. So that is how this one works. Very simple question, very simple solution. Now we can move on to the next one. You can also try it out with me if you want to. I will mute myself now. Okay, so I have solved the seventh question as well. It was sliding window maximum. We had solved this question previously as well when I was practicing DQ. That video might be up on the channel as well. You can go and check it out whenever you might want to. And I will just explain the solution briefly right now because I have already explained it in detail in that video. Although my explanation was quite poor, I would say, but it is what it is. I will explain it to you quickly. So what we are doing is, after taking the input for the vector and the window size, what I do is I create a DQ uh, which will act as a monotonically decreasing DQ. So basically the elements in it will be in monotonically decreasing order, although it will be containing the indexes. The indexes will be in increasing order, but the elements are in monotonically decreasing order, and we'll be storing indexes in this. So I just take an integer I that we will use to iterate the vector. I run a while loop until I is less than the size of the vector, and I have also created another vector called result. So first of all, after getting inside the while loop, I first pop out the elements from the front that are out of bounds, or basically out of the current window, by just checking if dq.front is less than equal to I minus k or not, and then I pop from the front. Then I have to make sure that the monotonically decreasing condition is satisfied from the back. So from the back I pop until the elements are less than the current value, and then I push in the current value, and then if the window size is correct, so basically if we have enough number of elements in the window, basically I is greater than equal to OK minus 1, in that case we can just directly push the result in the result, which is the front most element of the vector, which is going to be the most maximum element of this window, and then we just update I, then we just print out the output. This was it for this solution. Very simple question, very simple solution. I think the next question might be quite similar as well. You can try it out if you want to. I will mute myself right now. You can also try out the question if you want to. Okay, so as I said, the next question was quite similar and as even easier than the previous one. So what we had to do in this is I did not even need to use a DQ in this because I am not popping from the back in any way. I'm only pushing on the back and I'm popping from the front. So I could have used a normal Q as well, but anyways, that doesn't matter much. So what I did for this question is instead of keeping a monotonically decreasing order in the queue, I just stored the negative elements in the order that I am receiving them. So, and whenever I get into the while loop, the first condition that I check is if the element in the front is still in the window or not. If it is not in the window, then I can just pop from the front, and I do it until all the elements are in the window, all the elements in the queue are in the window, and if the element is less than 0, which means if it is negative, if the current element is negative, in that case I am pushing it to the queue, and then when inserting in the result, I am doing two things. First of all, I am checking if uh, the window is full or not. If it is not, obviously we don't do anything, and when the window is full, then we check if the queue is empty or not, because if the queue is empty, that means there is no negative element for this window. Then in that case you can just directly push 0. Otherwise, if the queue is not empty, you can just take the front of the queue and put it in the vector. You can take it and put it in the result, and then you can just print the result vector out. Very simple question, very simple solution. Now we can just move on to the next one. You can also try it out with me if you want to. I will mute myself now. Okay guys, so I have completed this circular Q question as well. Initially I was implementing it using a DQ, which was not the best solution because DQ takes extra space with each push and pop. So because of that, ChatGPT told me that I should maybe try implementing it using an array, and since we are practicing, I did exactly that. And I was also making a mistake that I did not understand fully initially what it meant by circular queue, so I just thought that uh, whenever we reach an element at the end and then we try to push again, since we cannot push at the end, it will start pushing from the front. Kind of, that's the way I thought of it, but it's not that. The thing is, whenever we pop the element, then the area where the elements have been popped, that can be reused, that part can be reused depending on the size of the queue. So the solution to this is quite simple. We just create a vector, we take the capacity, which is basically the size of that queue, you can say, and of that circular queue, the size of the circular queue, and then we take a variable called size to keep a track of the number of elements in the vector currently or in the queue. And we then take two variables, zero front, which is 0, and rear, which is -1. So rear is used to track the elements that are being added, and front is used to track the elements that are being popped. So whenever we push, first of all we check if size is equal to capacity or not, because if it is, then we cannot push any more elements as the queue is full. Otherwise we just do rear plus 1 modulus capacity, which will give us one of the indexes of the array, or the next index of the array after the rear, and then we put the new element and we increase the size by 1. Similarly, while popping, if the size is greater than 0, then what we do is we just increase the front by 1 position, so front plus 1 modulus capacity, and then we decrease the size by 1. So basically, as one element has been removed and the queue is empty by one element, so then just return just normal front and rear functions. I was also initially creating a top function. I forgot this is not stack, this is queue, so we only have front in it, and I implemented rear as well because it was asking for it. So anyways, that is it for now. Now we can move on to the next question. You can also try it out with me if you want to. It is the last one. I will mute myself now and try and solve this question. Alright, so we have solved the last question as well. The last question we had to basically solve the previous problem that we have solved of sliding window maximum, but instead of using a D queue we were supposed to use a priority queue this time, and since a priority queue is based on max heap and the topmost element of the max heap is always the maximum element priority wise, so the maximum element is always going to be at the top. So now we only need to worry about one thing, which is indexing wise, if the element is still in the array or not, or still in the queue or not. So what we did for this is we created a pair, and the first element of the pair is going to be the maximum itself, and the second is going to be the index. So the first is going to be the element itself and second is going to be the index. And then I use a for loop. We first of all pop elements from the top of the priority queue, or the front of the priority queue, you can kind of say, whatever top. In this case it is the top, so the top of the max heap until the elements are out of index, and then we place the current element in it, and if our window size is not if our window is not completely filled up yet, then we just continue, otherwise we push the topmost element, the maximum of the topmost element, which is the first of the pair, in the result itself, and that is how you solve it. If you wanted opposite of it, for example, right now this is taking the maximum element. If you wanted minimum element, in that case what we could have done is we could have did this vector pair int comma int comma greater pair comma int. I think this should work, or it doesn't seem to work. Let me just check. But isn't this what I have written? Parent comma int, correct, comma vector. Oh, there's a missing. Parent comma int. There is another missing over here as well. So yeah. So what you do in that case, you just pass in vector pair, vector of pair, and then greater of pair. So basically, if instead of a pair it was just integer, you would have passed a vector of integer and greater of integer. So that is the way you could have done it. There is a functor, this greater one. This helps basically reverse the whatever kind of sorting or anything is happening inside. So if you want to reverse it in descending order, or whatever you might want to call it, then you just pass in this accordingly, and that is the way we solve this. You know what, why not we test it out on different inputs that we have given, the minimum one. Let us test that out as well. That is 3 2 2 2 4 1, correct. And let us do the same thing with the other test case. So it is -1, -3, -3, -3, 3, 3, correct. This is also correct. So that's the way you could have done it. Now, for now, I'm going to try solving the bonus questions as well. You can try solving them along with me if you want to. The choice is yours. Now, since I'm practicing, I am going to be solving these as well. I will mute myself now. You can also try solving this along with me. Okay, so the 11th question, it seems like we are just supposed to return the k largest elements in it in an array. So this is very simple. Using a priority queue, you can do this simply. Just add all of the elements in the priority queue and pop out the top k elements. That is the way you can do it. For now, I'm going to be avoiding this question. I'm going to be moving on to the next one, which seems a bit difficult. You can also try solving it along with me if you want to. I will mute myself now. Okay, so we have solved the 12th problem as well. GPT was really bad at explaining this. ChatGPT was really bad at explaining this problem itself. I will explain it to you myself. It took me a long time to understand it properly, what it was trying to say, but I will explain it to you myself. So, when we say a k-sorted array, what it means is that every element in the array is exactly k positions or is at max k positions away from its actual sorted position in the array itself. So, for example, this 6, it it can either be in place of this 5, this 3, or this 2, since k is equals to 3, which is the distance that it is from its actual sorted position. So 6 can be in these 3 places or in these 4 places, you can kind of say. Similarly with 5 can be in these places and also over here, so 5 can be in total of these places. Similarly, for example, let us take 2. 2 can 2 can be in any of these positions, since all are at most 3 positions away. So that is what you have to understand, that each position is at most k positions away from its actual sorted position. So what we can do for this is we can use a priority queue of size k, and when we use this priority queue of size k, we will just, for each position we will just be popping the topmost element. Since this is a min heap priority queue, the minimum element is going to be at the top, so you are going to be popping the most minimum element for each position and just popping it in its place. So since k is equals to 3, we will be creating a priority queue of size k plus 1, because there can be a total of k plus 1 positions for that element, like ahead of it or behind it, you can kind of say. So for example, we are also counting the 0th index distance wise, so it can be at a distance of 0 from its current position, or its sorted position can be at distance of 1, or at a distance of 2, or at a distance of 3, which is k equals to 3. So that's why the priority queue is going to be containing 4 elements, which is k plus 1 element. So first of all, you run the for loop and you keep checking until your priority queue is full, and when your priority queue gets full, you just take the topmost element of the priority queue, push it in the result, and then you pop and push the current element. And then after coming out of the for loop, you are just going to be emptying out the priority queue and adding the elements to the result one by one, and then you will have the sorted array. I think this solution should work. Let me ask ChatGPT if this works. Although ChatGPT was very bad at explaining this problem, it would have saved me a lot of time if it was not that bad. But anyways, I hope I explained the problem to you well enough. If I did not, you can go online and search for other people's solution as well. So anyways, this is my okay, so this is it. By the way, the time complexity is going to be n log n, since for each element we are going to be popping and pushing from the priority queue, and it takes log of n time to push and pop from the priority queue, and there are a total of n elements, so it is going to be n log k. And the space complexity is obviously going to be k, because the priority queue, which is the min heap, is going to be containing at most k plus 1 elements. So that is it. So what it basically means, this solution becomes quite a bit optimal or really significantly faster if k is much lesser than n. So that is basically it. Check minor improvement, cleaner logic. Okay, same thing. Adding edge case handling if k is greater than equal to n. So Makes sense. If the k given to us is going to be greater than n, then you can just sort the array directly, because each element can be anywhere in the array, basically, you can say. So that is it. With this, we have solved all of the questions of Q, and all of them were quite good for understanding the applications of Q, DQ, and priority queue. I hope you were able to understand them, solve them, and if not, you can just keep practicing, ask for questions yourself, and solve even more questions if required accordingly. So with this, we are done with Q for today, and for next time, I think we are going to be solving questions of either sets or maps. We won't take long with that either. One video for that, then we can finally move on to something more useful like trees. So you can look forward to that. For now, I'm just going to go and eat my lunch. Have a good day. Bye.
So please whatever. Please I want to reach 1 million likes. So please sarapakarai. Yes. Okay, thank you.